In this lesson, we're going to learn about cycloalkanes. So cycloalkanes are cyclic hydrocarbons where there isn't a chain with a beginning and an end, but a ring structure where all the carbons are connected to one another in a loop. So here we have 4 carbons that are connected in a loop or in a cyclic structure. And so 4 carbons was bute, so this is going to be called a cyclobutane. 5 carbons, that is going to be called a cyclopentane, and 6 carbons in a ring structure is going to be called a cyclohexane, and so on. So we can have a cyclopropane, cycloheptane, and on and on and on. So we'll do a couple of questions as practice. So here we have, if I start from here where there's an attachment, 1, 2, 3, 4, 5, 6 total carbons. And off one of them, there is a methyl group that is attached over here. So when we do our numbering for attachments, because there isn't a clear beginning and an end, we are always going to start with the carbon that would give us the lowest numbering. So in this case, there's only one attachment, in which case we are going to make that carbon number 1, but also with only one attachment, there is where, however we draw this, we would just end up making that carbon number 1. So in a case like this, we don't actually have to even give a number. We don't have to do that until there's more than one attachment, and then we need to specify where those are in relation to one another. So this is going to be a cyclohexane because we have the 6 carbons in a ring structure, and there is a methyl group off of a carbon, and once again we don't have to say that that is the first carbon. So this is just a methyl cyclohexane. So if I were to draw this, if I saw the name, hexane means 6 carbons, cyclo means that those are connected in a ring structure, and then there's a methyl group off of one of the carbons. So over here I have, if I start down here, 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So 9 is non. So I have a cyclo-non-ane. And I can start at any carbon for numbering. But to come up with the lowest numbering structure, I'm going to start with one of the ends. So what I can see is here, there are 2 carbons in between these attachments. In all the others, there's only 1 carbon in between. And so that means that my lowest numberings would either start here and move in a counterclockwise direction or start here and move in a clockwise direction. So I can have 1, 2, 3, 4, 5, 6, 7. And then 8 and 9, but those ones don't matter. There's no attachments there. Or I can go 1, 2, 3, 4, 5, 6, 7. So here I have 1, 3 dimethyl and 5, 7 diethyl. In the other direction, I'd have 1, 3, 5, and 7 as well. So if I have the exact same number in both directions, but I have different attachments, now I have to figure out which one has priority. And so here, alphabetical is going to be the tiebreaker. So I have ethyl and methyl groups. So ethyl comes first alphabetically. Oops, sorry, and this is a 2, not a 1. So I'm going to start with the numbering I have here on the outside, where I have a 1, 3 diethyl and 5, 7 dimethyl, and then we had a cyclo-non-ane as the main ring structure. So 1, 3 diethyl, 5, 7 dimethyl, cyclo-non-ane. So because our numbering is the same either way, we have 1, 3, 5, 7 in both directions. There's no clear winner in terms of lowest numberings, and then we go to alphabetically what comes first with our attachments. All right, here's another example. So I have 1, 2, 3, 4, 5, 6 carbons in my ring structure. So that is going to be a cyclohexane. And then I have methyl and ethyl attachments. And so numbering wise, I'm either going to start here and go 1, 2, 3, or start here and go 1, 2, 3. Now we have the same thing happening here as in the example before, where in both directions I'm going to end up with 1 and 3 as my lowest numbering. So they're both equal in terms of our lowest numbering. So then our tiebreaker is going to be that ethyl comes first alphabetically. So I have 1 ethyl, 3 methyl, and then cyclohexane. And then we're going to look at another example here where we have 1, 2, 3, 4, 5, 6, 7. So a heptane as our chain, and 1, 2, 3, 4, 5. So a cyclopentane. And so in this case, the chain, the heptane, is actually longer than the ring structure, which is a cyclopentane. And so that is going to take precedence in our naming. That is going to be the root here, and the cyclo is going to be an attachment. So before we saw when we had, if I had 5 carbons as an attachment, 5 carbons is pent, and then as an attachment it would be il. And so we're going to use that, but we're going to specify that it is in a cyclic structure. So we're going to have a cyclopentyl. So as I number, lowest numbering is going to be from left to right. So off of the 3rd carbon, there is that cyclopentyl attachment. So I have a 3 cyclopentyl heptane.